Good afternoon to all. Now we will see the logistic regression program in this video. So this is the complete coding of the program. You all can see up to this the coding. Now we will see how to execute in the R Studio in the POSIT cloud environment. For that, first I copy the two lines, install packages. And going to the POSIT cloud environment. So I am creating a new file and pasting the code. Now I start executing by using the source option here. So this is the exact output. So it's running, all the packages are getting installed. This process takes few more minutes. We have to wait till the completion. After that we'll start giving the remaining coding. I think you able to see the coding. Still the process running. The process is going on running. Still it is running. So installation packages, you note down these are, if this is done correctly only you can able to do the program. So we have to wait till all the process completed. See how many time it takes to complete the installation of packages. You can see the installation, still it is going. It is running. When you are running your program, you should see the same messages in your screen. So we will wait until the process is over. I wanted to show the complete process, that's why I am recording all those steps. Now it is stop. So we'll go to the coding. We'll see the entire program, how it gives the results. For that I disabled two installation packages. Already we installed, no need to install these packages, so I removed those lines using the command lines. You can see here, put the command lines over here, then and remaining part of the program is copied over here. Now I am going to run the program using this source option. So if I compile this program, so it is running, you will get the output here. The output, this is the output window. In the output window you can see the dataset values. The dataset values, hours and results are displayed here. Then in the output window you can see the graph, that is the logistic regression curve is displayed. This is a sigmoid function. The x-axis and the y-axis values are displayed. The x-axis the values ranging from 0 to 10 and the y-axis values ranging from 0.0 to 0.8. The heading is displayed. This is the output of your program, logistic regression. So I'll give the meaning of the program source code, how it is executed, how the neural network modeling takes place. Now I will explain the program line by line. First two lines specifies the install.packages and CA tools and Caret. The CA tools for splitting the data into training and testing sets. This is the package to be installed. Next we have the Caret. The package is used for displaying the graph, to display the graph and curve. To apply the plot function, we use the Caret. Next, after installation, we have got these two lines, load libraries. So this CA tools and Caret should be loaded after installation. So we use the function library. Then we have got the next line is the data, the input data for logistic regression. It is called by using the data frame function. Inside the data frame, we declare the two variables hours and result. The hours value is given us some integer values, that is given as C of 1 to 10 is given. Then result is also given as the same. What the C specifies is converts the data in the vector format. So for first row it takes 1 0, for second row it takes 2 0. So in order to convert in a vector format, so that it is given as an input to the that is logistic regression. So to convert this list format to an vector format, this vector format only be processed by the logistic regression model. So we have to convert in a suitable format. That's why we are doing this process. Next we have the print data. So we know just printing of the data. The data has hours and result will be displayed, that we saw in the program output. Then we applied the function setSeed function. The setSeed function is used for specifying the training and testing data set. That how the training data set and testing data set will be split, and what basis it is to be split. Every time we are before running the program, how the values are split by using the set seed 1 2 3. So this 1 2 3 is the integer value, either maybe any value can be given. For example 99 or 100 can be given. Some integer value should be there. That is the seed function. Seed function is used to is mainly used for the training and testing. The values will not be changed during the next time for execution. So initially it is split into certain range, that is 70-30. 7:3 ratio. The same ratio is followed every time it is executed. That is, for that only we are using the seed function. Then we have the split function. Split function, what we are doing is we assume the so in the split function we assumed sample.split data result and the split ratio is given. So the split function assumes only the split ratio. The split ratio we have given 0.7. Then next the train data variable and test data variable. Train data takes what the value is given for train data. A split is equal to whatever the split value is true, that those data will be taken for train data, and the split value is false, those values will be assumed for test data. So in these steps we assume the values we assign the values for train and test data. So now we have got the values in the train data and the test data. The actual data is split in two categories, train data and test data. We have got the values in the train data and test data. Now we are going to give the linear regression. We are going to perform the linear regression by using this line model, which is equivalent to GLM of some parameters given. GLM means logistic regression model, which takes 3 parameters: result, then data, family. The logistic regression can be performed by using the binomial function. The actual logic behind the logistic regression uses the binomial function. So binomial equation, sigmoid and all we already discussed in the theoretical part. So that is the model parameter is given as binomial. Data is for training the neural network, we assume the train data, and the result value is approximately is given as hours. Result depends on the hours. Next, summary of model. The summary displays some values. These are the values are displayed. Summary of these are the values displayed. So these values, what it's intercept and hours. These parameters are not used by the program. These are actually used for evaluating the logistic regression equation. This is automatically generated. If you know the formula, you come to know what is intercept. This is the formula. This is the actual formula. The first parameter B0 is the intercept. B0 is the intercept. So this is the logistic regression formula. Those values are displayed there. This is the equation formed by the logistic regression model. Based on this equation only, it classifies the data is class 1 or class 2. So we see an example here. So how it classifies, we receive the final values 0.027. This 0.027 is represented in percentage 2.7. So 2.7 less than 50%, 5% out of 10. So chances significant is very less. So the probability value determining for the pass or fail is less than 5, we assume it's a fail. Greater than 5, we assume it's a pass. That is the thing we get. So 2.7% less than 50 means it is fail category only. That's what using this formula it is calculated. This is actually happening. That is the model. Summary of model statement we used above. Next line we'll see. Next we have, after summary of model, probability predictions is equal to predict model new data. So these line is useful for testing. Test data is taken as an input and the result value stored as a type in the heading response. Then this model is syntax. This is the probability predictions. We have the test data results. So now we have the results in the probability predictions. Next we have print probability predictions. We are just displaying the probability predictions, whatever, to know what the outcome was. For that we use this print probability predictions. Next, based on the results, we perform the operation if else probability predictions greater than 0.5, then it is classified as 1, otherwise it is 0. So whatever the result received, the result value is greater than 0.5 only, we give the category of the class as 1, otherwise the other values are set to 0. So we are segregating the resultant value obtained by the probability testing results and true or false category, whether the class 1 or class 2 category. For that line, for this purpose only this line is used. Next we have print. All those values are printed by using the print command. Next we have the confusion matrix. In the confusion matrix you can see the commands as.factor, class predictions, as.factor, test data result. So confusion for this statement as.factor is useful for converting data from one format to another format. What format is been changed means that is the numeric format to the factor format, and then only that is the graph will be displayed in the system. The numerical that is the neural network output predictions values are converted into a factor format for visual display. That is, the process is being done here. Next we have the plot function. The plot function, we know normally we are declaring the x-axis and y-axis, x-axis headings and y-axis headings, then variables hours and result. Using the x-axis we use the hours and y-axis we use the result. Then we use the heading in the main. Then PCH is the plot character, values set as 16. Next we have the curve. This is the actual curve to be displayed, a logistic regression curve. So we specified the parameters for plot, the graph to be displayed using the plot function. Now the curve actual data is to be fetched from the predict model. Then add function equal to set to true. Then the line value will be color set to blue. Then line width is also given to. The values are taken as the output of the model, and the type value is response. This is the actually testing data result. Testing data result is set as the testing data result. We assumed it's a response. See here, type response. So the response value is assumed for displaying the graph. Type value is response. So this is how the graph is displayed. So plot function is used to specifying the parameters for the graph. The data is the curve function is used for displaying the logistic regression curve. With that, this is the output of the program. I have shown the output in the RStudio. You go through the program line by line once again, and if you have doubt anything, you can comment and ask. Thank you.